Hello students, we continue our discussion on the chapter circle. So our first problem for the day is, in the figure given below, O is the center of a circle. If AB and AC are chord of the circle such that AB equals to AC and OP perpendicular to AB and OQ perpendicular to AC, we need to prove that PB equals to QC. Now, this is a circle with center O, AB and AC are two chords given which are equal in length. OP is perpendicular to AB and OQ is perpendicular to AC. So, we need to prove that QC is equal to PB. Now, to prove that, we consider these two triangles and prove these two are congruent to each other. Once we prove these two are congruent to each other, then by CPCT we come to the conclusion that PB equals to QC. Now see, OM is perpendicular to AB and ON is perpendicular to AC. Now, if a line is drawn from the center perpendicular to the chord, so it bisects the chord. So, we can say that AM equals to MB, AN equals to NC. And since AB and AC are equal, therefore, half of the part of both will be equal to each other. That means half of AC equals to half of AB. So, we can say that NC is equal to MB. Now, these two are equal chord. Equal chord are equidistant from the center. That means OM equals to ON. Now, OP equals to OQ because they are radii of the same circle. So, from the radii, if we subtract OM and ON, the remaining part, that is QN and MP, are also going to be equal, and one angle is 90. So, this way we are going to prove the congruency. Let us see. Since OP is perpendicular to AB, so we write AM equals to MB equals to half of AB. This is our relation 1. OQ is perpendicular to AC, it is given. So, we can say that AN equals to NC and this is half of AC. Here we are using the theorem that if a line is drawn from the center to the chord and if it is perpendicular to the chord, then it bisects the chord. So, from 1 and 2, we come to the conclusion that NC equals to MB because AB equals to AC is given to us. Now, OM equals to OM because equal chord are equidistant from the center. I explain you using the diagram, and OP and OQ are two radii. So, if you subtract OP minus OM and OQ minus ON, so we will get MP equals to QN. This is equation 2. Now, we consider the triangle QNC and PMB. So, QN equals to MP using B, NC is equal to MB using A, and one angle is given as 90 degree. Therefore, these two triangles are congruent to each other, and once it is congruent to each other, by CPCT we can say that QC equals to PB. Moving into the next problem, in the given figure, chord AB and CD of a circle with center O intersect at E. If OE bisect angle AED, that means angle AEO equals to OED. So, we have to prove that AB equals to CD. This is our problem. Two chords are given to you. One angle bisector is given to you. So, we need to prove that these two chords are equal. Now, what we do, we drop a perpendicular OM perpendicular to AB and ON perpendicular to CD. So, we consider the triangle ONE and OME. One angle, it is 90 degree since we drop a perpendicular. OE is a common side, and angle OEN equals to angle OEM since OE is given as the bisector. So therefore these two triangles are congruent. Now by CPCT we can say that OM equals to ON. Now OM and ON are the distance of the chord from the center. So if the chords AB and CD are equidistant from the center, it implies that chords are equal. Therefore it implies AB equals to CD. Thank you students for watching this.